In all of our earlier examples where we found the domain and range of a function together, we are using the graph of a function. However, we know that functions can be represented in a couple different ways. Functions are most often represented graphically, using an equation, or using a table of data. And so in our next couple examples, I want to talk about how to find the domain, and we won't worry about the range, but just the domain of a function from its equation. Finding the range from the equation is a bit more difficult of a task, and that's not something we're going to ask ourselves to do. So there's a couple things we have to remember or keep in mind when we're trying to find the domain of a function from its equation, and here the function we are working with in this first example is f of x equals 1 over x squared minus 9, and we have to remember the domain is the set of all inputs or x values, and this is going to be the set of all x values that we can actually plug into our function's equation and get an output that makes sense. So there's a couple things we have to watch out for to help us figure out what the domain of a function is from the equation. So division by 0 is something that could occur in this function, right? Because we have some variable in our denominator. So this is the one we're going to have to pay attention to for this example. We won't necessarily run into these other scenarios for this first example, but they might show up in other examples where we need to find the domain from the equation of the function. So the other things we are not allowed to do is we cannot take the even root of a negative number. So we cannot take the even root of a negative number, and what we mean by an even root is like a square root, a fourth root, a sixth root, an eighth root, a root that corresponds to an even number. We can take the odd root of any number, including the negatives, right? You can take the cube root of -8, -1, or any negative number. That works just fine. It's the even roots we have to be careful for, but there's no square roots or radical signs showing up at all in the equation of our function, so this isn't going to be an issue for this example. And we may add to this list as time goes on, but the third thing we want to watch out for, at least for now, is that we can't take the logarithm of a negative number or 0. So as long as we can avoid these kind of three operations with the equation of our function, then that x value will be in the domain of our function. So it's actually sometimes easier to think about what x values are not allowed in our domain, and then our domain is everything but those x values. And so here, for the function 1 over x squared minus 9, we know we cannot divide by 0. We can never divide by 0, so we have to avoid division by 0 at all costs. And that means our denominator, x squared minus 9, cannot be equal to 0, which means that x squared cannot be equal to 9. Here I'm just solving this like I would an equation, although it's an inequation. And just finishing that process off, we see that x cannot be equal to +3 or -3. So this is probably the quickest way to describe the domain of our function 1 over x squared minus 9. X cannot be equal to +3 or -3. But if we want to use some of our other notations, like maybe interval notation, our domain would be the open interval from -infinity up to -3, that first x value we have to avoid, in union with the interval from -3 to +3, going up to that other x value we have to avoid. And then we can do anything to the right of that last x value at +3. So another way to describe our domain using interval notation is seen here. So finding the domain of a function from its equation can get kind of crazy depending on how complicated the equation is and how many of these operations are combined or composed together. But we shouldn't look at anything significantly more difficult than maybe just one or two of these rules being broken at the same time. All right, let's go ahead and do another example together of finding the domain of a function from just the equation of the function, and we're not interested in finding the range here. And so now our function is 1 over the square root of the quantity 5 minus 3x. So remember, the things we have to think about and avoid are division by 0, taking the even root like the square root of a negative number, and taking the log of a negative number or 0. Well, there's definitely no logarithms involved in the equation for our function, so we don't have to worry about this last issue. But we do have a variable in our denominator, so we have to worry about division by 0. And we also have a square root in our function as well, so we have to avoid taking the even root of a negative number. And so all of our issues are really kind of consolidated down here in our denominator. So we know we cannot divide by 0. So that means 5 minus 3x cannot be equal to 0. And we also need to make sure that thing underneath our square root, our radicand, if you will, has to be positive as well. And so that quantity 5 minus 3x has to be greater than or equal to 0 to avoid taking the even root of a negative number. But if we think about that first condition where 5 minus 3x is not allowed to be equal to 0, then we can really consolidate or combine these conditions together. So after combining those two conditions together, we see the real condition that has to be met in order for an x value to be allowed in our domain is that x has to be such that 5 minus 3x is greater than 0. As long as this happens, then that quantity 5 minus 3x, which ends up underneath our square root and in our denominator, will never be 0 or negative, so everything will work out fine. We don't want to leave our domain as this unsolved inequality. We should definitely go ahead and solve it. So if we want to solve it, we can add 3x to each side and then divide both sides by 3. Remember, we're not dividing by a negative, so we don't have to flip that inequality sign. And so here is our domain. In its inequality form, x is less than 5/3. Although usually we write the variable on the left-hand side, so if we just flip that around to make it more standard, we can see that the domain of this function found from just the equation of the function is the set of x values such that x is strictly less than 5/3.